In today's video, we're going to work on some exercises to practice on the rules of indices. And without further ado, let's just jump into question 1. Simplify the following. A. 3 squared times 3 to the power of 6. The rule that we are going to apply here is to sum the powers when the base of the same numbers are multiplied by each other. Here 3 is the same base, so we can add the powers, which is 2 plus 6, which is 3 to the power of 8. Question B. 3y squared multiplied by 3y to the power of 4. I need you to notice right here that the multiplication operations happen between 3 and y as well. And the one more thing is that the square and the power of 4 is only applied to the y variable. So in this case, we can have 3, which is also by the power of 1, multiply y squared, multiply 3, multiply y to the power of 4. So if 3 is multiplied by itself for 2 times, or you can also add the powers of 1 plus 1, you have 3 squared. And then for y, you can add the powers as well, which you will get y to the power of 2 plus 4. In the end, you will get 9y to the power of 6. Question C. 4x to the power of 6 multiplied by 2x. Again, we can break it down to have the coefficients multiplied by each other and the variable x multiply each other, and we add the powers together. So 4 times 2 is equals to 8x to the power of 6 times x, which is x to the power of 7. Question D. X to the power of 6 divided by x to the power of 4. For this kind of question, we're going to apply the next rule, which is the two numbers of the same base is divided by each other. We're going to take the powers and subtract them. In this case, x to the power of 6 minus 4, which is x to the power of 2. Question E. X to the power of 5 over x. So you can understand the fraction as a division operation as well, which is x to the power of 5 divided by x. And in this case, x is by power of 1, so we can have x to the power of 5 minus 1, which is x to the power of 4. Question F. 15x cubed divided by 5x cubed. Remember we mentioned before that all of the numerator will be divided by all of the denominator. And in this case, what we can do is we can break it down so that the coefficients of x, which is 15 and 5, divide by each other, so 15 divided by 5. And then for x cubed, it is also divided by x cubed. So in this case, 15 divided by 5 is equals to 3. X to the power of 3 minus 3 is 0. And if you remember the rule, anything to the power of 0 is equals to 1. We can simplify this final answer as 3. Remember also that you don't have to break down the question like this. If you understand what is the underlying concepts that help you find the answer, you can just simplify directly on the fraction just like this. And in the end, you will still find the same answer, which is 3. Question G. 16x squared y squared divided by 4xy. If you know how to simplify directly on the fraction, you're supposed to get 4xy. So that's the 16 divided by 4, x squared divided by x, y squared divided by y. Question H. X squared raised by the power of 2. This is the other rule that you want to multiply the powers when one number raised by a power is raised again by another power. So if you multiply 2 times 2, you get 4. Your final answer should be x to the power of 4. Question I. 3x squared y squared in brackets raised by the power of 2. So for this, you want to remember also when the bracket applies, then the power on the outside of the bracket will apply to every number in the bracket. So you have 3 squared, and then you have x squared raised by the power of 2, and then you also have y squared raised by the power of 2. Then you can apply the same law again to multiply the powers. So you have 9x to the power of 4, y to the power of 4. Because you multiply the powers, 2 times 2 is equals to 4. Question J. X squared over y in brackets divided by 0. Okay, we're going to do the same thing. We're going to apply all of the powers from the outside of the bracket to all of the numbers inside the bracket. So you have x to the power of 2 times 0 over y to the power of 0. Anything to the power of 0 is equals to 1. So in this case, 1 over 1 and your final answer is 1. Question K. 4x squared y cubed in brackets raised by the power of 2 divided by 2xy raised by the power of 3. If you understand everything that we just discussed, this should be no problem. So what you will get is 4 squared multiply x squared raised by the power of 2 multiply y cubed raised by the power of 2 divided by 2 cubed multiply x cubed multiply y cubed. And then if you simplify the powers, you should get 16x to the power of 4 y to the power of 6 divided by 8x cubed y cubed. And then from there, you're going to simplify it further because there's a division operation right here. So we can simplify 16 divided by 8, x to the power of 4 divided by x to the power of 3, y to the power of 6 divided by y to the power of 3. So your final answer, you should get 2xy cubed. Question L. 2 to the power of negative 5. So for this is another rule, which is that when you apply a negative power, you can do a reciprocal and change the power to a positive one. If you have 2 to the power of negative 5, you reciprocate, you will get 1 over 2, and then the power becomes positive, so by power of 5. If you simplify this, you get 1 over 32. Question M. xy in brackets to the power of negative 2. When the powers is outside the bracket, again, we're going to apply it to both of the numbers in the bracket. But then this time, the power is negative, so we're going to use the same rule again, to apply a reciprocal and then change the power into a positive. In this case, you have 1 over xy in brackets to the power of 2. And if you want to distribute the powers into all of the numbers in the brackets, you can have 1 over x squared y squared. Question N. 8x y to the power of negative 3. This one is different from the previous question because there's no brackets. So in this case, the negative 3 power is only applied to the variable y. So 8x can stand aside. And then y to the power of negative 3, we can reciprocate 1 over y and then positive power, so y cubed. And then you get 8x over y cubed. Question O. 12x to the power of negative 3, y to the power of negative 4. All of this is same as the previous one, and you should be able to get 12 multiply 1 over x cubed multiply 1 over y to the power of 4. And then from there, you can simplify everything. 12 divided by x cubed y to the power of 4. Question P. 2x squared to the power of negative 3. All of the questions that you've been doing, it's about the same thing. The only thing is that the two possibilities you can find, which is when you have brackets and when you don't have brackets. So for x squared, there's no brackets, so meaning to say the square power is only applied to the x. But for the negative cube power, then that's applied to the entire bracket, so we will have 1 over 2x squared in brackets to the power of positive 3. And if you distribute the powers, you get 1 over 2 cubed multiply x squared cubed. And then simplify the square and the cube, you get 1 over 8x to the power of 6. Question Q. X to the power of negative 3 over x to the power of negative 4. You don't really have to overcomplicate this because even though it looks difficult, all you have to do is apply the rule of subtracting the powers when you see a division operation. And in this case, you can take x to the power of negative 3 minus negative 4. If you take double negatives, it means it's a positive, so negative 3 plus 4, you get 1. So in the end of the day, you actually just get x to the power of 1. Question R. 8 to the power of 1/3. For this one, the rule is if you have a power raised by a fractional index, the denominator of the index is how you will root the number. So 8 to the power of 1/3, the denominator is 3, so we're going to do a cube root of 8. Question S. 216 to the power of 2 over 3. And so in this case, the numerator is not 1. But how we're going to work around this is actually very simple, because we're just going to use the numerator as the power of the base number and the denominator will be on the root. So it will still be a cube root, but it will be cube root of 216 square. Question T. X to the power of 1/3 multiplied by x to the power of 1/3. You can apply the first rule to add the powers together. So you have x to the power of 1/3 plus 1/3, which is x to the power of 2/3. And then only you simplify it as a root. So meaning to say you have cube root of x square. The square coming from the numerator of this fraction and the root, the cube root, coming from the denominator of this fraction. Question U. X to the power of 6 divided by y square, in brackets, raised by the power of half. Okay, so if you normally see bracket questions like this, your best options is to actually try to get rid of the brackets. How are we going to get rid of the brackets? We can just distribute the power of half into the brackets first. So we have x to the power of 6 times half over y to the power of 2 times half. So after you've multiplied everything, simplify the fractions, you will get x cubed divided by y. The last question for today, question V, we have 9x to the power of 1/3 over 12x to the power of 4/3. The way you want to have a look at this is that you want to see the division operation, 9x to the power of 1/3 divided by 12x to the power of 4/3. And in this case, you can use the coefficient to simplify each other first. That will give you 9 over 12. And then x, you can take the powers and subtract. So x to the power of 1/3 minus 4/3. And after you simplify, you get 3 over 4 x to the power of -1. So the -1, again, you can apply reciprocal and remove the negative. So you'll get 3 over 4x to the power of 1. And that is it for today's video practicing on the rules of indices. For any questions or concerns, you can check the description box or leave a comment below. And I will see you in the next video. Take care.